Okay, convert the equation into standard form by completing the square, where the center, the vertices, foci, and endpoints of the minor axis. So this will be an ellipse, and to convert it into standard form, we need to complete the square on the variable. So what I'm going to do is group the variables in descending order. So I got a 4x squared and a plus 16x, and then I'm going to group the 9y squared and the minus 18y, and then I'm going to move the 11 to the other, or keep the 11 on the other side. So to complete the square, I need to factor out any coefficient on the squared term. So the first thing I'm going to do is factor out a 4 from these two terms, and I'm left with x squared plus 4x. And I'm going to leave a little room to complete the square, plus 9 times y squared minus 2y, and that equals 11. So what I did is I grouped the variable terms and factored out the coefficient on the squared terms. Now to complete the square, for the x's, I know that I need half the middle term squared. I need to add 4 inside here. So when I add 4, remember now, what happened is this is actually a 4 times 4. So really what I did is I added 16 to the left side. So I need to make sure that I rebalance the equation and add 16 to the right side. Now I'll do the same thing for the y's and complete the square. And if I take half of the middle term, that's negative 1, and square it, I get plus 1. But again, when you add a 1 in here, it's actually multiplied by 9. So when I do that, I basically added 9 to the left side. So I want to make sure I add 9 to the right side. So now everything is completed. All the squares are completed, so I can write the left side as 4 times. This would be an x plus 2, the quantity squared, plus 9 times a y minus 1, the quantity squared, and that equals, and if I add up all the numbers on the right side, I get 36. Now finally, to complete writing the equation of this ellipse in standard form, I need to divide each side by 36. So I'm going to divide everything by 36 so that my right side becomes 1, and that's what I want in my standard form. So I just need to make sure I divide every term on the left side by 36. And by doing so, we'll be able to cancel. We'll be left with an x plus 2, the quantity squared, over 9. So if you notice, the 4 will cancel with the 36, leaving a 9 in the denominator. The right side will be left with a y minus 1, the quantity squared, and that will be all over 4. And that's because the 9 and the 36 cancel, leaving a 4 in the denominator. So I have my standard form for the equation of this ellipse. The center can be taken right from the translations of my variables, so the center is going to be at negative 2, 1. So I'll go ahead and graph the center on my graph. Here's the point, negative 2, 1. A and B. A is equal to 3, which is taken from the denominator underneath the x terms. So a squared sits underneath the x terms. So a is equal to 3, which I like to call my horizontal radius. So I know from the center, if I go right and left 3 units, I'll be at the horizontal vertices of my ellipse. So this would be at the point of 1, 1, and this would be at the point negative 5, 1. I'll do the same thing with B. B is taken from the denominator of the y term. So B is equal to 2, which is the square root of 4. I like to call this my vertical radius. So from the center, I'm going to go up and down 2. If I go up 2 and down 2 units, that puts me at the point negative 2, 3, and negative 2, negative 1. So in this case, the major axis will be the horizontal axis through my center. The minor axis is the vertical axis through the center. So the endpoints on the minor axis are the -2, 3 and the -2, -1, which are here and here. So now I can just draw my ellipse connecting those points. Let's see if I can do this. And I got the ellipse sketched. Now the foci, when you use the c, I know that c squared is equal to a squared minus b squared. So in this case, c squared is equal to a 9 minus 4, or equal to 5. So c is equal to the square root of 5. So the foci lie on the major axis. So from the center, I'm going to go left and right along the major axis, the square root of 5. So the first foci would be at -2 minus the square root of 5, positive 1. And the second foci would be at -2 plus the square root of 5 and 1. So -2 plus the square root of 5 would be right about here, and -2 minus the square root of 5 would be right about here. So this would be f sub 1 and f sub 2. So if we approximate those values, I'll just plug them into my calculator here. -2 minus the square root of 5 is about -4.23. So that was this point. This is approximately a -4.21. And -2 plus the square root of 5 would be approximately 0.21. So that would be the f sub 2.